Okay, welcome back. So, back in, I think it was lesson 4.2, we were just kind of learning about functions, and I had asked you to write a method that determines whether a number is prime or not. So this method here accepts just one int parameter. I'm calling it n, so that's the input. This is wrong. This should return a Boolean. So this method is going to take in a number, and then it's going to return either true or false, whether that number is prime or not. So for instance, a number like 17 is prime because the only factors are 1 and 17. There are no other factors that go into 17. So 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it. So a prime number is a number with only two factors, 1 and itself. Another prime number would be 7, okay, or 23, or 11. Okay? But a number like 12 is not prime because there are more than two factors. So 2 goes into 12, 3 goes into 12, 4 goes into 12. So 12 actually has quite a few factors. Okay, so I want to be able to say system.out.println and then isPrime 13. And then this should print true. Okay? And then if I do another line, and if I were to say, something like, actually, I'm going to change that to 17. And then if I did something like 28, then this should be false. Okay. Now, of course, this won't work at all because I haven't done my code down here. Okay, so hopefully you've done this question already, this method. But if not, let's just talk about this for a second. How would I determine if a number is prime? Well, let's look at the number 17. So I've whipped up a little Word document here. And basically, we need to use a loop. And I'm going to ignore 1, and I'm going to ignore 17 because 1 goes into 17, and 17 goes into 17. So we're assuming n is 17. So I can ignore 1 and 17 because those are always going to be factors of n. So what I'm going to do is make a loop where I starts at 2, and then I check to see if that is a factor of 17. And I can do that by saying if n, which is this number, in this case 17, mod I, and I is 2, if that is equal to 0. In other words, if 2 goes into 17 evenly with 0 remainder, then if that's true, if 2 goes into 17, then that means this is not prime. Okay? So if this is true, I can return false, meaning n is not prime. Now, if 2 is not a factor, so if the remainder is not 0, then what I'm going to do is check the next value. So check 3, and then check 4, and then check 5. And I'm going to go all the way to the end, up to 16. And I'm going to check all these numbers to see if any of them are factors. Okay, so this is the algorithm. Now, how would we code that? Well, we simply make a for loop where I starts at 2. So don't start it at 1, start it at 2. And I is going to go up to but not including n. So I didn't put an equal sign, take that off. So I is just going to go up to but not including the number n itself. And then I plus plus. So I is going to go up by 1. And then inside this loop, so we're going to tab. Inside this loop, we're going to say if n, which is the original parameter, the original input that's coming in, if n mod I is equal to 0, then I'm going to return false. So if this is true, for any value of I, if this is true, then that means n is not prime, and I'm going to return false. Okay. Now, some people make the mistake of saying else return true, and this actually will not work because then that will only check one value of I. It would only check 2, and if 2 doesn't go into n, you're automatically returning true, and you're not checking the other values of I. So we want to stay away from doing this. Okay. Basically, we're going to let the loop run. So I is going to be 2, 3, 4, 5, 6, 7, 8, 9, all the way up to n. And if this thing never ever becomes true, then that means the loop is going to stop, and then I'm going to return true. So the only time I'm going to return true is if this loop completes. If this loop goes all the way up to n, and if this thing never ever became true, then I'm going to return true. And that means n is prime. Okay, hopefully you followed that. So we're basically just checking all of these numbers from 2 all the way up to n minus 1, which in this case is 16 for this example. And if one of these values goes into 17 evenly, then I'm going to stop this whole loop and return false. It can't be prime. But if I get all the way through to the end and I never find a factor, then that means I'm returning true and I have a prime number. Okay, so if I run this now, this should work. So if I look at my main method, I've got 2 examples. I'm printing isPrime 17, which should be true, and isPrime 28, which should be false. So let's have a look. I'm going to compile and run it. And I get true and false, which is perfect. Okay, let me just make that window a little bit smaller. I lost it. Okay, that's better. All right, now, what if I'm going to take away this line, and I'm just going to look at this one. So what if I made this number really big? So what if I made this number over 2 billion? Now, I actually did a quick Google search, and I looked for really large prime numbers. So I looked for one over 2 billion, but under 2.1 billion, because I don't want to go over the integer maximum value, which is 2 to the power of 31 minus 1. Okay, so I'm taking this value right here, and I'm going to put that into my program. So 2 billion, 38 million, 74,743. Okay. So that, according to this website, is a prime number. So I want to see if my program works and if it tells me that this is true. Now, this loop is going to go a long way. This loop is going to go from 2 all the way up to this number, 1 less than this number. Okay, so let's see what happens. I'm going to compile and run it. Okay, so the program is running. And to force view it, I'm going to go View, Show Terminal. Okay, the program's running, but it's not done yet. Okay, there, it just finished. So you can see that it took a little bit of time. I'm gonna run that one more time. Okay, so you can see it. 4, 5, 6, 7, 8, 9, 10. Okay, so about 10 seconds it took for this loop to run and to determine if this number was prime. Okay, so what we're going to do in just the next couple of minutes is try to make this faster. So can we make this loop faster? Can we make this method run faster than 10 seconds? So if we think about the math here, so I'm going to go here and just erase all of this. Okay, let's do a simpler example where let's assume n is 28. So I'm not going to do quite that super large number yet. So let's just look at 28. So if I write down all the numbers from 1 to 28, okay, and what we're going to do is cancel the first one and the last one, 28. So I is going to check all of these numbers from 2 all the way up to 27. Now, the question is, can we do this faster? Like, do we have to run the loop all the way up to the end? Well, if we just think about this for a second, if I go halfway, okay, isn't it true that all of these numbers will never ever be factors of 28? So I shouldn't really even have to check 15, 16, 17, 18. All of these numbers, if you look, 15 does not go into 28, 16 does not go into 28. It's impossible mathematically. It's impossible for any of these numbers to go into 28. So really, in my code, I'm making my loop run too long. So I don't have to go all the way up to n. I really just have to go up to and equal to n divided by 2. Okay? And so that will make our loop run twice as fast. But we can do even better than this. And this is a little bit harder to figure out, but we can do better than halfway. So if we just think about this mathematically here, okay, does 2 go into 28? Yes, it does, so I'm going to circle it. Now, what is the cofactor of 2? Meaning 2 times what gives me 28? Well, that would be 14, so I'm going to circle that. So 2 and 14, they're called cofactors. They're partners. Okay, they both multiply to give me 28. Now, does 4 go into 28? Yes, it does. So I'm going to put a box around that. Okay, 4 goes into 28 7 times. Okay, and then of course 1 and 28 are also cofactors. So they also multiply to give us 28. But there is this kind of mysterious region here. So there's a border. There's like a border line that splits one factor from its cofactor. Okay? So on one side of this line, you're going to get a factor, and on the other side of this line, you're going to get its cofactor. And basically, if there are no factors here, so if there are no factors in this region, then mathematically there are going to be no cofactors in this region. It just works out that way. If you don't find any factors here, then you're never going to find any factors here. So really, the loop, we can do much better than half. This loop really only needs to go up to this value. And that value is the square root of n. What is n? N is just the number that we're determining whether it's prime or not. So really, my loop only has to run up to the square root of n. We can do much better than halfway. So if we go back to our code, we really just need to make this loop go up to the square root of n. Like this. Okay? And then I'm going to cast this to an int. Actually, I don't have to, because I will just go up to that value. Okay? So if I compile that, all right. So let's see what happens now. This program should run a lot faster than 10 seconds. So originally it took 10 seconds to run. Let's see how this modification changes things. So I'm going to compile and run it. And let's see. First I'm going to show the terminal. Okay. Actually, I'm going to clear. Okay, and here we go. We're going to run it. And let's count how many seconds. So before it took 10 seconds. Let's see now. So I'm going to press OK. Right away, it says true. Let's try that again. I'm going to clear it, and we're going to run this. And not even 1 second, not even half a second, the answer comes up. So basically, we went from 10 seconds to milliseconds. So just by making this mathematical change and thinking about our algorithm, thinking about our program, we can make this program run much, much faster. And in the world of creating software, time is money. You basically want these programs to run really fast. You don't want the user to have to wait seconds and seconds for the output, for the answer. Okay, so there is the most optimal isPrime method. And I would like you to know about this. Okay. So if you have any questions, feel free to ask in class. All right. Thanks for watching.